All right, today we are taking notes on similar figures. The first thing that we're going to talk about are congruent figures. So congruent figures have the same shape and the same size. So you're going to fill in those blanks in your notes. So if they have the same shape and same size, they're exactly the same figure. And we need a symbol for that. Our symbol is going to look like an equal sign with a little squiggly on top, and that means they are congruent. Which also means they're the same. Okay, we're going to draw two figures that are congruent. We're going to label those A, B, C, and then our second triangle we're going to draw is D, E, F. So when we look at these triangles, they are exactly the same shape and same size. And if you notice how we labeled the angles, their angles are exactly the same. So the corresponding angles or the matching angles are going to be exactly the same. Their corresponding sides are going to be exactly the same. Everything is the same. And we can write a congruency statement that says triangle ABC is congruent to triangle DEF. I'm going to write that above. All right, now we are going to move on to similar figures. Now, similar figures have the same shape, but they have a different size. So it's going to look like the same triangle, only smaller or bigger than the original one. And the symbol for similar is just the squiggly line that goes above the congruent symbol, and it means similar. We're going to draw two figures that are similar. One will be a smaller figure. We'll label that ABC. And then we're going to draw the same shape, but a bigger size, and it's going to be triangle DEF. Now, again, the angles in these similar triangles are exactly the same measurement, so they are labeled with the angle measurement that is exactly the same, and we can now write a statement that says triangle ABC is similar to triangle DEF. We're using that symbol for similar. All right, in the next section, it asks us to draw a similar example. So if we look at our first figure, our triangle, we're going to call it triangle XYZ. It has sides that are 2, 2, and 3. When we draw a similar triangle, these sides are going to be proportional, and they're going to change the same way. So it's going to become a triangle that is 4, 4, and 6. Notice the angle measurements are still the same, and we've labeled our angles, and everything increased by a factor of 2. So it doubled in size. Now, triangle XYZ is similar to triangle NOP. And we can write that statement. Now, when we look at this, we can see that side XY is similar to side NO. And we can now also know that XZ is similar to NP. And finally, YZ, side YZ, is similar to side OP. And we put that little similar symbol between there. Now, it also asks us for a non-similar example. So if we think about it, for a non-similar example, if one side stays the same and the other two sides change, then that is not similar. So notice here, it has the 4 and the 6, but the 2 stayed the same. The other sides doubled, so that is not similar. For it to be similar, everything would have to change in the same way. All right, so we're going to fill that in, make sure we understand. What a similar figure would look like. All right, in the next section, these are important notes. So we want to fill this in, what we have learned about similar figures. So we're talking about similar figures. And we know that the corresponding angles are equal. You could also say they are congruent, okay? So you're going to write equal or congruent. And then the next statement is very important. It says the lengths of the corresponding sides are proportional. And that's very important because we just learned about proportions, and we can make a WKU to solve these similar figure problems because they are proportional. So make sure you have put a star by that and you know that the side lengths, the corresponding sides, are proportional.
All right, so now looking at example number 4, it says that we need to use a proportion to solve for the missing side. So we are going to be making a WKU to help us solve for x here. So normally when we have WKU problems, we have a word problem where we can circle all the numbers and look for all the labels, but we don't have that this time. So we have to think of our own words so we know where these numbers go. So the first thing I'm going to do is find x. So I'm going to put a circle around x. And now I'm going to look on that other shape and figure out which number goes with x. Which number is on the same part of the triangle as x is. And I'm looking and I'm seeing that 3 feet is going to be right there. Now I'm going to look for that other number that was on the triangle, and I'm going to put a square around that 5. And I'm looking for what matches the 5 on that smaller triangle, and that's a 2. So now as I'm looking at the W part, I'm going to use those shapes that I just used to mark the numbers to help us set up the WKU. So I'm going to decide that I want circles on top. So I'm going to make it circle over square. Now I have to figure out which triangle is K and which triangle is U. So remember, K stands for what you know. So as I'm looking at those triangles, I'm thinking to myself, which one is the one that I know everything about? And that's that smaller one. So I'm going to put a little K in the middle. And that means that my unknown is on that bigger triangle. So I'm going to use the U there. So on my K triangle, I'm looking for the circle to go on top. That's going to be the 3. And the 2 is going to be on the bottom because that was my squared number. And now I'm looking at the U triangle. The X was circled. That needs to go on top. And the squared number was 5. Now, we already are very, very familiar with solving a WKU, so we're going to pause the video. I want you to practice solving this out, cross-multiplying and solving, and we're going to come back and make sure that you have the correct answer. All right, go ahead and look at my answer up here. I got x is equal to 7.5 feet. Make sure you have the label and the correct answer, and we're going to move on to example 5.
Okay, the next problem is problem 5, and it is overlapping triangles. So when we see triangles that are overlapping, we want to make sure we use the entire side length and not just part of it. And it gives you a hint that you can draw the triangles separately to help you see the sides. So when I'm looking at this picture, I can see a small triangle that is inside the larger one, and you can see I'm outlining it in blue. I'm going to draw that, and I'm going to label the side F8 and the bottom X. Okay, just like it is in the triangle. Then I'm going to go ahead and draw my larger triangle, and the side of that is 18, and the bottom, across the bottom, I can see that it is 20. So I'm going to go ahead and label that 20 on the bottom and 16 on the side. Okay, once I do that, I am going to be looking at my triangles, and I'm going to try to set up a WKU, because remember, when we have similar triangles, they are proportional. So the first thing I'm looking for is my X. And I'm going to draw a circle around it just like I did before. And then I'm going to find the corresponding or matching side on the other, which is 20. So I've circled those. Now I'm going to look for the other side, which is an 8. And I'm going to put a square around the 8 and around the 16, because those are corresponding sides. So now I'm setting up my WKU, and just like I did before, I'm going to do circle over square. Okay, so I look at my known triangle. This time it's my larger triangle is the known, and the smaller is unknown. So I'm going to do circle, which is 20, over square, which is 16. And then I'm going to look at my unknown, and I'm going to put circle X over the 8. Now we're going to pause the video, and we're going to let you solve it. All right, so make sure you got 10 as your answer, and now we're going to look at the next overlapping triangle. Here we can see that there is a small triangle within the big triangle, so I'm going to draw that, and it has dimensions of 3 and 5. And then I'm going to look at my larger triangle. Now there's something special about this larger triangle that we need to notice. This big triangle has a length of x on the bottom. Okay, so the bottom of that triangle is x, but on the side, I know that that top part is 3, because I know that from my first triangle, and then it looks like the bottom section is 6. So to find the whole length, I'm going to need to put those two measurements together. So I'm going to need to add the 3 and the 6 together to get a total length on the side of 9. So you need to make sure that you label that 9 on the side and x on the bottom. Now I just go ahead and set up my WKU. We'll get that set up, and then we're going to let you pause the video and solve it. Again, remember, you can circle your x and circle the corresponding side, and then put a square around the other measurement and its corresponding side. And then go ahead, set up your WKU. Okay, check your answer. X should be 15, and now we're going to move on to the back.
All right, now example number 6 has pictures of triangles, and as I read this, it's going to sound very, very familiar to other problems that we've done for WKU. But the nice thing is that they gave me a picture to help me look at this. So this problem doesn't actually have an x, it just has a question mark, but remember that's the same thing. So the first thing that I want to do is find that x and circle it. And now I'm looking on the other triangle, and I'm looking for what number matches it, what goes with it. And now I'm at the other number on the triangle. I see the 10. I'm going to put a square around that. And I'm going to square the 4 because the 4 goes with the 10. So now we're going to pause the video. I want you to try setting this up with circles over squares and see if we can get the same answer. All right, remember the person was what we knew both values for. So that was my known ratio. The tree had the unknown that had that x. So when I solved that out, I got 12.5 feet. Make sure you have the same as me before we move on. Now in number 7, they do not give us a picture, so we're going to draw one. This time I have a building that is 70 feet high. So as I read it, I'm going to draw the pieces that I need. That building is 70 feet high that casts a shadow that's 150 feet long. If a nearby flagpole, I'm going to draw a flagpole, casts a shadow of 60 feet, how tall is the flagpole? So now that I've drawn this picture, we're going to pause the video. I want you to try the whole process on your own this time. All right, so I got an answer of 28 feet. Make sure that all of your work matches mine and you have it all copied down before we move on to the last example, number 8. So we have some blanks to fill in here. That first blank is scale drawings. They are enlarged or reduced drawing that are similar to an actual object or place. So remember that word enlarged actually means bigger. That's another way to say it. And reduced means smaller. All right, so now that we have that copied down, I'm going to move down so I can see this. We've seen a problem exactly like this. I just wanted to make sure that we pointed out something very specific. They give us this big picture, but we actually don't even need it for this problem. The only thing that I'm noticing is that scale at the bottom of the picture tells me that 1 centimeter equals 5 miles. And when it gives me that scale factor there, that is a known ratio. So when I do my WKU, I'm going to use those two together as the K. And then the last number that I'm going to use is that 8 centimeters. And now I want you to try setting this one up on your own. All right, so in our last example, you should have gotten 1x equals 40. And remember, that just means the same thing as x equals 40. So you should have gotten 40 miles. And that concludes our notes on similar figures.
Yes.